friends, welcome back to my class in the series of learning data structures through C. In the previous video, we discussed about the types of data structure. Well, in today's video, we will discuss about arrays in data structure. We will see what is array, how to declare an array, how to initialize an array, and we will see the operations that what we can perform on arrays. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. And watch the video till the end. Do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. So this is the types of data structure that what we discussed in the previous video. So we have primitive and non-primitive. Well, I have discussed what is primitive, what is non-primitive, all those things. Please check out the playlist of the data structure. You will get an idea of what is primitive and non-primitive. You have the linear and non-linear data structures. Under linear data structure, here comes the array. So in today's video, we will discuss about this array data structure. Array is the linear data structure. The name itself tells you it is the data structure which helps the user to store the data in a linear fashion one after the other. So let's get into the actual definition. So array is the collection of homogeneous elements. Homogeneous elements means elements of similar type with a common name. So we will have only one single name, a common name with which we can access all the elements. And the elements are arranged one after the other in the adjacent memory location. Means one after the other means continuous memory location we will have. When I say the elements are stored one after the other in adjacent memory means the memory will be continuous. How the memory will be continuous and how I can store the elements into the array, let's see one by one. So before that, let's see the declaration of the array. So here we have the data type followed with the array name and the dimension, or we call this as size. That is how much elements I can store. We all know the single variable can store only single value. So we come to this data structure where I can store multiple values. It is homogeneous collection of elements. I can have multiple values, but it should be of the same type. That is what homogeneous. Homogeneous is similar type of data. If I say I want to store integer values, I can store only integer values. I cannot mix up with float or double or character. That's what it says. Homogeneous means similar type. So let us see the example. I say integer, array name A and the dimension is 10, which says I can store 10 elements. Maximum 10, not more than that. It can be less than that also, but the memory is wasted. You can also learn about these concept of arrays in detail in the playlist of C programming language. So now let's get into the memory representation of this arrays. So here we go with the memory representation of arrays. So as I said, we have a single variable and this single variable can store only single value. So I have a memory block X and say it is of integer type. Depending upon the machine that what we use, the memory will be allocated. Let us assume that it is 2 bytes. So here it is consuming 2 bytes of memory. Say the address is 201 and 202. 2 bytes of memory for X. And I can store only one value in this variable. Right? If I want to store one more value, it is not possible with this. I have to go with one more variable. I have to say y equal to 20. So again a new memory block will be created. Again 2 bytes will be allocated. Say something like address say 401 and 402. 2 bytes of memory. So it is 2 bytes of memory. Say the value is 20 like this. Just imagine you want to store 100 values. It's quite difficult to manage with 100 different variables. And hence we go with arrays. Array says you can store multiple values, but with one constraint saying that those multiple values must be of the same type. And memory will be continuous. So how the memory will be continuous and how the elements are stored one after the other and how I can access that with a common name, that we need to learn now. So this is what the array declaration. So we need to mention the data type followed with the array name. And the dimension I am saying 5. 5 says maximum 5 elements I can store, but not more than that, it can be less than that. If I store less than the dimension, there will be no loss for the user, but there will be a huge loss for the system resource. Memory is wasted. I say I can store 5 elements and the memory will be allocated for storing all the maximum elements. But if I just store only 3 elements, the remaining memory will be wasted. That is a major drawback of arrays because it is predefined and it is homogeneous. If I just talk about the features of arrays, array is homogeneous and array is predefined. Due to its homogeneous characteristics, I cannot store different type of values. Due to its predefined size, I cannot store more values during runtime. Once the size is fixed, it is fixed. I cannot change it during runtime. I say I want to store maximum 5, you can store maximum 5 and less than 5 also, but not more than 5. So it is predefined. So once it is defined, I cannot change that. I cannot precise it, nor I cannot increase it. I cannot shrink the memory also. So immediately when the compiler encounters this variable declaration statement, what it is going to do? It is going to allocate the memory based on the data type and the dimension. The data type is integer and the dimension is 5. So to store one integer value, I require 2 bytes. To store one, if with respect to 16-bit machine, it is 2 bytes. If it is 32-bit machine, it is 4 bytes. So it depends upon the machine that what we use. So let us assume it is 16-bit machine. So it is 2 bytes. To store one integer value, I require, integer means whole numbers. To store one integer value, I require 2 bytes. And the maximum elements that what I can store is 5. The dimension is 5. I have mentioned as 5. So I can store 5 maximum values. It can be less than that also, but not more than that. So one integer, 2 bytes, 5 into 2, totally 10 bytes of memory, continuous memory has to be allocated. And hence we say array is a block of memory that can store elements one after the other continuously, because memory will be allocated continuously. Let us assume this is what the memory that we have got here. Let us assume it is from 101. Actually saying the address will be in hexadecimal format, but just for understanding the address easily, we are writing with normal numbers. You can have hexadecimal numbers also, but it's quite difficult to interpret. So let us take normal numbers to understand the address. So the address is starting from 101. So as I said, I can store 5 maximum elements and it is of integer type. So as soon as the compiler encounters this declaration, this is what array declaration. This is array declaration. What it is going to do, it is going to check the data type and the dimension. Dimension means what we call it as size. So it is 5 into 2, 10 bytes of memory to store one single value, 2 bytes. So totally 10 bytes of memory has to be allocated. Let us assume it is from 101. So it is 101, 102 the first element, 3, 4 second, 5, 6 third element, 7 and 8 fourth element, 9 and 10 fifth element. And how do we refer to each and every element? As I said, it is a common name. If I say I want to access the third element, I cannot simply say yay. It is a common name, of course. But how do I access each and every individual element in the array? Means I have to take the help of this index. What do we call it as? Index value or subscript value. And the subscript value always starts from 0. Right. So the first element, right now I have not initialized it. If I initialize it, the values will be fixed. Right now, just memory will be allocated. So totally 101 to 110, totally 10 bytes of memory is allocated. The first element will be stored in A of 0, then 1, A of 2, A of 3 and A of 4. And each element requires 2 bytes. So this is one frame, second, third. This is complete frame. In this complete frame, I can store 5 elements of integer type. And if I want to say, I want to access the first element, the index value is a of 0, and if I want to print the address, it is only 101. I cannot say 101 and 102. I need to say only 101. Then second element in a of 1, the address is 103. Third element in a of 2, it is 105. Fourth element in a of 3, it is 107. And the next element in a of 4 in 109. And remember, we have to use square brackets for representing the dimension of the array. So this is the array memory representation. I have shown you in the horizontal fashion. It can be in the vertical fashion also. A of 0. So each and every element is accessed with its unique index value, which always starts from 0 to n minus 1. If I want to store some value, what I can do, I can initialize it. This is array initialization. So I am trying to initialize the value into the array. Well, of course, I can also take during runtime also. How to take during runtime? We will see that in the next video. But now we will see how to initialize it. So I have initialized the set of values within the square flower brackets, open brace and close brace, and the set of values are given and separated with the comma operator. Now these values will be stored like this. Say the first element in a of 0, 10, 20 in a of 1, 30 in a of 2, 40 in a of 3 and 50 in a of 4. And just observe, the memory is continuous. That is what consecutive memory location. The memory will be allocated continuously and we access the elements with its unique index value. This is array initialization. Hope you have understood the basic things of array. What is array? What is the array declaration and array initialization? The next class, in the next video, we will see the operations of arrays. So, well, all the operations that what we can do, I have discussed in the previous video itself, and those operations will be explained in separate videos. So that's all for today's video. See you in the next video. Till then, take care. Bye-bye.